Hello everyone, good morning to everyone in my time zone. Today I'm streaming in a different condition on completely different time, I'm sorry. So the reason is that I need this design finished as soon as possible. So yeah, this is why I can't wait until Thursday afternoon. So it's Tuesday morning and my task is simple. I need to finish the PCB layout, the complete PCB layout. Now we are in the state that there are components roughly placed around the PCB near their final positions, and I need to start with, or we are going to start with, the component placement. Then we will switch to the PCB layout. The fact is that I have as much time as I need, because as I said, I need this design to be finished as soon as possible. So I will stream today until the end of the job. If it's 2 hours, 3 hours, I don't know, but I have all time I need because I need this design. I can see that I have to change the sticker running on the bottom line. Yeah. Something like this. Yeah, we are working on PCB layout. So basically we can start. It's 7 o'clock in the morning, so please be patient with me if my brain isn't working at full speed. That's possible that I will have some issues with my lingo or with my design skills, but I think it will be good. So I will use the split screen mode as usual, because you need to see what I am doing. So as I said, there are some groups of components that are to be placed on a spot near where the components are now. I'm designing this PCB for myself, so my waveform generator is on the right side of my desk. So when we look at this PCB, on the right side there will be inputs from the generator. We are talking about these two BNCs and two terminals. On the top side, top edge, there will be entry for the external power supply and for the measurement output, and for the external device under test power supply input. On the right side, there are two BNCs for debugging outputs, or checking where is the edge of the switching signal, and as well as two terminals for connecting the heavy load. It means a load in the order of ohms or tens of ohms, and input for light load. This is in usual measures like 100 or more ohms. And all the components that enable switching, it means the Smith buffer, the gate driver, MOSFET, transistors, freewheeling diode, and some LED signaling for the outputs and for the inputs as well. So I will work gradually on the component placement, and I can see that there are some comments, so I will periodically check the comments. Mustafa, hi, thank you, how are you? Yeah, definitely, I will help you. Please, if possible, send me a message on LinkedIn, and I will take a look after the show at your problem, and I will definitely propose some solution. So thank you for the comment, and please send me a DM, and I will process it as soon as possible. Thank you. So let's start with the input for the heavy load, like channel 1 input. So it's a BNC, so I think I can place the BNC not at the edge. I think I can place it like when the body overlaps the PCB. Let me check the data sheet, and I will show you the data sheet as well, so you can see this is the particular BNC I'm using, and here is the drawing. I'm looking for a recommendation where should be the edge of the PCB. You can see that there are like small legs besides the big bossing LEDs that go through the PCB. So definitely this mini leg must be placed on the PCB, and the distance between this mini leg and the edge of the body is unknown. There is no distance mentioned in the drawing. So I have to make a guess, because I don't have the particular piece on hand. What I have is the official 3D model, so you can see these LXR things I'm talking about. So we can use the 3D model. So I will put the BNC. Yeah, but we need to check it in here. We can go a little bit further. Yes. I think something like no, it's too far. It's too close to the edge. So 1 millimeter back, I think. -1. Let's check the 3D model. Yes, I think that's perfect. Okay, so the position between the PCB edge, when I hit the space, I can zero the auxiliary scale on the bottom line of the KiCad. So here is the 0, and roughly the opposite edge of the body, of the connector body, is 12.27 or 12.3 millimeters. Okay. So this will be roughly position of the BNC, and I think I will place the the terminal like here. It's a screwless terminal, like push-in terminal, so I can operate the clamps, or yeah, the spring mechanism from the top side with a screwdriver. So it means the terminal can be placed rather close to a BNC. So let's say at this position, we can't forget to place the mounting hole. As you can see, I already placed the top left mounting hole near the corner, and we need to do with all the mounting holes, at least with the top right mounting hole. So the best thing to do that is to use the position relative 2. I will use the relative position of this corner, so the center of the mounting hole will be minus 4.5 millimeter from the corner, and 4.5 millimeter downward. The item, not the item, the, yeah, I'm sorry, I hit the escape instead of choosing the point here. So now we can see that there is plenty of space between the mounting hole and the BNC, so I can keep it. I think we can save our PCB area. So I can place these two screw terminals as close as possible together. So it means that I can use two terminals, like two 2-pin terminals, or one 4-pin terminal. So we have to check the pitch of the terminal. In the datasheet, of course. Here is 3.5 millimeter is the pitch, 2.5 millimeter is the distance from the pin to the edge of the terminal. So it means that two 2-pin screw terminals will be 5 and 3.5, 8.5 millimeter far from each other. Let's check it. So this will be 8.5 millimeter from this one. Perfect. Now both terminals are in a place that I can use one 4-pin terminal or two 2-pin terminals. Or not? I think I can. No, it doesn't work, because there is, yeah, it doesn't work. I can't place the 4-pin terminal, because then the distance between this pin and this pin must be 3.5, and now it's 5 millimeters. Yeah, so it doesn't work. There can be two 2-pin terminals only, not one 4-pin terminal. So I'm sorry for the confusion. Anyway, we can continue. So now I can use the same function as here. I don't know what's the rough distance. I will use it only to get the horizontal space, horizontal distance. Yeah, something like this. Now I can move this a little bit lower. The reason why I don't use the favorite feature that I can hit the M key, like for move, then press the cursor key down, and then I can use my mouse because the vertical axis then is locked. This feature doesn't work in KiCad number 905. So before they correct this, I need to improvise a little. I already, let's say, announced this on the official KiCad forum, but they advised me to install the testing 906 version. I didn't do that because I don't have time for testing some. I don't have time to test some testing versions. I have to work. So anyway, before they correct it, I will use alternative way of work. So we have 3 important components for the input entry section. This is the resistor, the protection diode for the optocoupler, and the actual optocoupler. So I am using the pack and move footprint feature. By pressing P, you can grab the selected components from the schematic, and it makes a pack of them, and you can grab it and place them near your actual location. So here is the optocoupler, here is the diode. There will be placed like this because it protects the internal diode, internal LED of the optocoupler. And here is the protection resistor, or the current setting resistor, let's say. Can be placed like this. Okay. I'm placing components for the channel number 2. So for this. I'm thinking about the placement of the optocoupler. This optocoupler is not to provide me with a sophisticated isolation distance. Like, I don't need the clearance of the optocoupler. I only want to have the possibility to isolate the ground of the waveform generator with the ground of the switch. Because when these 2 components or instruments are supplied from a different voltage, different mains phase, etc., it can make issues with the grounds. So this is why I placed this jumper header, to be able to connect these 2 points, these 2 grounds. So I think we can go with this, or like this. Yeah, I think it's better to save some time. I started with the PCB dimension of like 80 to 80, or 80 to 80. That's the optimal size, I think, because I need some stability on the desk, and but if it works, the PCB can be even smaller, because 70 times 70 or 70 times 80, that can work as well. So now we have the LED, the Smith buffer, and another BNC, which is located on the opposite side. Okay, I'm just thinking if the position of the BNC measuring like the edge in the center of the circuit is optimally placed on the left edge of the PCB, because it's quite far from the input one, and we need some space for the MOSFET. So maybe I change my mind, either by placing them on the bottom edge, it means that the top edge, top BNC or channel 1 BNC should be facing upwards, which is not very something I want. We can place it here. Here is the light load entry. Yes, light load entry. Here is the voltage input. Yes. So let's say the MOSFETs will be near the load entries. Yes, like here. Okay, where to place these BNCs? Let's start with these boys. These are big terminals. 762. So this one will be placed somewhere here. This one will be 762, and we have I think this is the distance. Yes. I need to place these test points near the edge of the PCB. The reason is that I want to use the hook grips on the cables, and when the hook grip is close to the edge of the PCB, I don't need to use the soldering. Yeah, I don't need to solder. I don't have to solder the wire. I just use the hook grip. Yes, and 1.27 is like, I think, good distance. Obviously, there is some Cartier issues with the footprints, but I will solve it by moving the terminals far from the edge of the PCB. Now I'm preparing the situation for the terminals and to see how much space will be there for the MOSFETs, etc. So these two terminals can be moved like 1 millimeter far from the, yes, like this. Exactly. Now we said that this is the input 2. Yes, the bottom line are terminals 4. Yeah, I will place it here. Here is the edge, and we said 12.3 is the distance. Roughly, it's a testing instruments. It doesn't matter if there is like one-tenth of a millimeter error. Like this. That can work. I'm going to place the bottom edge, like bottom left mounting hole from this corner. Yes, and it means I need these components to be like centered or symmetrically around the center axis of the PCB. So on the other side, it means that these components can go lower, and as well it means, for for first that I canceled the distance now, like this. Okay, it can work, and it means that the PCB can't be lower or shorter. The 80 millimeters height should be kept. I can place the last mounting hole near this corner. Okay, that can work. So these are heavy load, light load terminal, the auxiliary measurement for the edges. Yes. Here is the power entry of the DUT power supply and the main measuring outputs. Output. Okay. Okay, it can work. Let's check our comments. No other comments. So I'm sipping my morning tea because today it's going to be 2 hours plus of talking. Not easy to me. So okay, so let's take it as a rough component placement for these 4 BNCs and 4 terminals. Yeah. Okay, it can work. It will be a board full of BNCs, but yeah, this is what it is. We are designing a measuring instrument, so there must be some entry and points and outlets for the signals. Yeah, we have to measure it. Measure them. Okay, so let's continue with the channel 2 as we started. So LEDs, LED for the fast check. Below the optocoupler can be a nice spot, like in the center of the PNC, of the optocoupler. Yes, so it will blinks or light constantly when the frequency is too fast, too high. But we have to have this feature to check the function of the connected generator and the switch, etc. Now the buffer with the, it's not a buffer, it's inverter, I'm sorry, that's inverter, because this optocoupler's output transistor act as a inverter with a missing working resistor. Yeah, I forget last time to place the working resistor. The LED with its resistor can work like a working resistor, but with some non-linearity, and I don't know if it can make an issue or not, because for the measurement we are talking about microseconds. We have to distinguish between. So yeah, definitely this way. So this is inverter with some output stage signalization with LED. The inverter, second inverter, it means the signal is in the phase with the input entry signal. Now the 0 ohm phase gate driver, gate resistor, 2 MOSFETs, etc. Okay, so let's annotate the schematic and update the PCB from the schematic. Okay, so we have 2 resistors, 2 new resistors. This one is for the channel 1 or channel 2, this one for channel 1. Okay, so this is channel 1 to be placed near the optocoupler, near this resistor, because in fact this resistor is in parallel with the combination of resistor and LED, like this. Now the buffer with its decoupling capacitor. Yeah, I think we can go below. There is plenty of space below. Hi Joel, thank you. Thank you for watching. Thank you for the comment. Thank you for confirmation. Yeah, I will use it as you said. Thank you. So something like this. Ideally, I want this space, or at least like this area to be dedicated to the heatsink for the MOSFET. The same for the channel 1 MOSFETs. There are 2 of them. So this is why I am like steering the pathway for the signals downwards, and then yeah, I will go back to upwards because I need this area to be undivided, unsplitted for the usage as a heatsink. So maybe it started strangely because yeah, I'm going downward, but yeah, it has its meaning. It's a working component placement, and it's possible that it will be changed during the PCB layout or during the component placement for the top for the channel 1. I'm just yeah, this stream is uncut, unfiltered. You can see my mistakes. You can see that I don't know where to place the components. I'm just looking for the best position in the process. So if you want 0 mistakes design stream, this is not the correct one. The output from the MOSFET is, from the gate driver is 5. Okay, it will be like here. Okay. Yeah, the position of the LED is a little bit lower than I wanted, but I think it doesn't matter. Okay, so now the MOSFET with its gate resistor and the freewheeling diode. Okay. This is the terminal for the load. So it means near the pin number or pet number 2 will be the drain of the MOSFET. And you can see that I will rotate, I will mirror vertically this terminal because I need the pad where the drain of the transistor will be to the top side, like on the edge of the combination of the terminals. So yeah, later. Now the light load channel, this is this one. So the gate resistor can be placed here for maybe further changing. So I need it accessible for my soldering iron. This is a good position. This is why I chose the 0805, because not for the easier solderability, easy to remove is the 0603, but I believe that the 0805 is more robust and more, yeah, not so error. I'm looking for the correct word. Yeah, less error prone, exactly. This is what I wanted to say. So the pad number 5 is drain, and drain will be connected with the pad, and it's the main cooling element of the transistor. The source will be grounded, so there will be polygon with stitching vias. Here is the gate with the signal from the gate resistor, and the area here will be indicated as a heatsink. Like the polygon will be like L-shaped, or we will see. And the freewheeling diode is connected between the drain and the ground. It's a protection diode for the inductive load to protect the transistor. You can see that there is a substrate diode inside of the transistor, but it's too tiny, it's too subtle. We have to use a robust big diode as this one is. I chose the 100 volt 5A diode in a big package, rather big package. The subtle substrate diode wouldn't be enough to protect the drain from the overvoltage when switching inductive loads. Okay, we said that here is the dual jumper for some kind of measurement and for ability to switch on constantly of the, like, short circuit the drain source circuit of the MOSFET. So yeah, this will be connected with the polygon. The ground will be on the probably inner layer or on the bottom layer. Yes, it's rather far from the drain, but it will be connected with a big polygon, so it will work. So let's wait for the rest. Here is the output signaling protection diode for the LED, because the maximal reverse voltage of this LED is 5 volts, and I'm designing this switch to be used for the power entries up to 100 volt. So when the transistor is switched off, the current would flow from the load through the light or heavy load resistor through the LED to the 5 volt auxiliary power supply, it means that 95 volt would be as a reverse voltage of this LED, so the LED would definitely go away in a millisecond. So here is the 200 volt protection diode, 250 actually protection diode for this LED. So we have to place these three components in a way that it is somehow symmetrical to this power entry or signal entry LED. So let me place it and then we will see. I personally don't know how it will work. So the input LED, output LED, the big area, big area for the heatsink, the cutting off or constantly switch on for the MOSFET. Here is the big heatsink area. I think it will work, and if not, then I will correct it. Okay, so let's work on the channel 1, which will be mirrored. It will be symmetrical, and here will be the axis of the symmetricity. So what is here will be mirrored here, basically. As I said, we can start with mirroring of this terminal. It will have multiple benefits. For instance, that these two pads will be connected to VCC and are close together, so it can be connected with elegant polygon. Otherwise, it will be like over the central pins. This composition is much better, and I have to replace these mounting holes like this. And this. Okay. So let's start from the bottom up. With one difference, there are two MOSFETs, not one, not only one. So again, I will place these two-way header minus 5.8 millimeter far from this one, which makes the possibility to, oh, okay, I chose. Oh, why it doesn't work? Where is the center of the pin number 1 is center of the footprint? Probably yes. This. In this case, the footprints overlap, but I have the possibility to use either two pieces of 2x2 headers or one piece of 2x4. Yeah, you understand, I think, fully. Now the MOSFETs and the freewheeling diode. Somewhere here, MOSFET number 1. MOSFET number 2. Something like this. Now the power entry circuits. So these 4. There will be some symmetricity issues because I can't rotate the BNC, but anyway, it's not a big issue. Previously, I placed the resistor here. Good morning, Adam. How are you? Okay. What is the drain? Number 4, yeah. Thank you. As well, I'm doing great. Yeah, I accidentally took the Schmidt inverter from the channel 1 because I lost track of my work. No, that's the correct one. As I said, it's rather early and it takes some time for me to or for my brain to work at the full speed. Plus, I'm constantly checking the symmetricity or mirroring of the components at the bottom. And it takes some focus that I'm lacking now. Okay. It doesn't have to be symmetric. That's only my pet peeve. To get some symmetricity. Pin number 2 is power entry. Yeah, as I can see, I will need some space for the traces. So it should be placed further from this capacitor. There will be a mix of 2 voltage domains, 10 volt and 5 volt. Nothing like pleasant, but not a big deal. I have the 10 volts, at least 10 volts for switching the MOSFETs to reach their lowest resistance. Okay, then the LED circuit. So on the bottom edge, the LED is at the same level as the power entry. No, signal entry LED. So let's say this. This is the yeah, number 3 is input. Yes, this is why there is no space for the components as before, because we have the coupling capacitors here. So I think I can use something like this. I think I need more space for these 3 components, because naturally 3 components take more space than 2. Okay, and I have to take care about this circuit and this terminal and this terminal and this terminal and the PNC. So I think these components must be moved a little bit downwards. Yeah, we'll see. Let's start with the big ones and then Yeah, we will see. So this is the main, yeah, the main BNC. This is the power entry, which is, yeah, these are the screw inputs. And this terminal must be rotated. Yes. This BNC will be 12.3 millimeter. No, this edge. This edge. This terminal will be rotated as well, but I changed accidentally the grid. Oh. Okay. Did I measure correctly? It's too far. Yeah, the mounting holes are rather big. Okay, quite big. I think I set 1.27. No, it's not possible. I measured incorrectly. This is the edge. This is the center. 1.87, not 27, 87 or 1.9. Okay. It means that we have to save space. While moving the entire thing downwards. I'm using the snap to graphics always, and sometimes, as you can see, when I getting close to a group of components, it snaps. So the solution is to zoom in and to place the group of components or the component that way, because otherwise it snaps to the graphics nearby. But I use the snap to graphics always because it more often helps than don't help. So this is why I keep it. Yeah, I think I can place only the active components downwards, and the connectors can stay symmetrically around the center axis of the PCB. Yeah, like this. I'm thinking about this thing. You can see that there is like very crowded upper edge of the PCB, and accidentally there is a channel 1 with 2 MOSFETs, which is not very good for the design. The better cooling performance for these MOSFETs would be to have bigger heatsink area. So I'm thinking that this bottom channel will be changed to the heavy one with 2 MOSFETs, and the upper one will be the light load switch because of the lower area for the heatsink. So let's change it in the schematic, because I need to change the components for the signal path unchanged. So what I will do is I will replace this MOSFET and place it here, while changing the test description, which is not a big deal. And that's it. Now the channel 1 is light load and channel 2 is high load. So let's update the PCB from the schematic. Yes, and the extra MOSFET, which is this one, must be placed here, which is definitely better spot, because the area at the bottom of the PCB has or will have the better cooling capability of the MOSFETs. There can be like this big heatsink area, while here at the top, just 2/3 of or half. Okay, I think that's a good move. Now let's continue with the terminals. And we are 1 hour in the show, so probably I will have a short break. Yes. So while you are waiting for me, or definitely, no history. Definitely, you can jump over this, but in the meantime, you can check my new KiCad tutorial on 𝗲𝗏𝗀, which is called KiCad for Makers, and you can design with me this PCB. So let's take a look. It's on 𝗲𝗏𝗀 courses, KiCad for Makers, or just use the search and type makers. And after a while, hopefully, no. So use the entire phrase, KiCad for Makers. This is my first course, and the second one is where? something strange. I have to get back to the site administrators, because somehow beginners and courses for other topics. Why is that? You can go through the instructors. Here are my courses, but yeah, the search engine doesn't work. Anyway, please give me a minute. I'm back. I'm back in a minute. So I'm back. Let's check the comments. Good morning. So back to our terminals. Yeah, this is the power entry for the auxiliary power supply for the logic. Very simple thing. Yeah, definitely these two screw terminals, yeah. I will use them because usually I connect the power supply with cable hooks, not with the terminals. What was the distance? 4.2. My brain is sleeping. Why to measure when I can place next to the terminal next to the other one? So in the corner, there will be a spot for the LED, the LDO circuit and the entire power supply. I moved the mounting holes far from each other because it seems position was too close. Not because of the electric safety, but because of the manufacturability. The copper area will be quite narrow, not close to clearance, but I like it more this way. Now the transil, the TVS. Transient voltage suppressor. The LDO with one leading decoupling capacitor, input decoupling capacitor, and the battery of 5 at the output. I checked last time that the maximal capacitance is not mentioned in the datasheet, but 50 microfarads are not too high capacitance to be placed at the output of the LDO. And I need this capacity battery, low ESR capacitive battery, to provide some peak currents, very short, narrow, but rather high current peaks for switching on the MOSFETs. So this is the reason for these components. No, I'm wrong. And last time as well, I was wrong. I will supply the gate driver from 10 volts. So not from the LDO. The LDO is only for LEDs, of course, for the optocoupler and for the inverter. So as you can see, only LEDs and this section. The gate driving circuit is supplied from 10 volts. So it means I can significantly reduce the capacitor battery here, which save a lot of time on PCB, and as well it makes the entire circuit simpler. This way, yes. The 5 volt is only for logic, yeah. As you can see, unfiltered and uncensored design stream is full of mistakes, full of corrections, full of overcorrections and getting back steering wheel to the left side, to the right side, as the entire hardware design job. This is not a big deal. This is a very simple circuit, but yeah, I'm making mistakes. And this is what it is. So where to place the LDO? We have two possibilities. Here, I can move the logic circuit a little bit below, a little bit downwards. I can place the TVS here and use this area for the LDO. With its decoupling capacitor near the pin 3. And the other one near the pin 2, which is combination of these two pads. Yeah, that can work. What are these? Yeah, I clearly remember that I placed these pins for the alternative possibility to supply the board from outside, like where the voltage should be changed or something. I will replace them with the soldering pads, because there is very nice spot for them here below the mounting hole, and that makes more sense. Like here. Annotate. Okay. One thing, when I plan to I'm not planning it, but there is a possibility that I can sometime change the voltage to 3.3 for just a sake of testing. I don't know if there is that feature, the possibility of using this feature. I have to isolate the output of the LDO, because the best way would be using a jumper. But the probability of using the external 5 volt or similar voltage is very low. And if that happens, I'm ready to unsolder the 0 ohm resistor. Most of the time the 0 ohm resistor will be soldered. So let me do this. This is the 5 volt zero ohm resistor. This will be like 1.9. And the other one. In fact, sometimes I use this mounting holes in the corner as ground points as well, because it's comfortable. Always comfortably accessible and always grounded. But this way works better. So what we have? We have placed components in a draft version, let's say. Let's check the render. Signal entries with terminals. I have to remember, I have to keep in mind that there will be labels for the terminals for each of them. So there is some space. Okay, definitely there will be rounded corners. As you remember, I placed the mounting holes 4.5 millimeters far from the corner. It means the ideal radius for the corners is 4.5 as well. Okay. Because of the minimal price difference between two-sided PCB and 4-layer PCB, I will use 4-layer PCB. Yeah, I think last time I already edited these. This board setup configuration. Yes. Okay. So let's say that both inner layers will be dedicated to ground. So I will create polygon with both inner layers connected to ground with thermal reliefs, yes. Because of the manufacturability, I will manufacture it by myself. Okay. What I can change, and I will, is the parameters of the thermal reliefs. The gap is okay, but the spoke width is too narrow. I am changing it to 1 millimeter. So yeah, you could see that the spoke width is much better, and it's comparable to a solid connection, but with much better solderability. I don't need to visit these two layers, so I can hide them. And now I can see only the wires, or yeah, the rat's nest wire that need to be connected. Okay, so I think 0.5 millimeter PCB track is the optimal starting point. Yes, and this, yeah. I'm checking the BNC. This is the entry side of the signal. Yes, that is connected to the ground in the quotes, because the ground connection, the true ground connection is done by placing a jumper here. Otherwise, it will be isolated from the instrument ground on the rest of the PCB. Okay. All terminals will be connected with a thick track to improve the robustness of connection. There will be a polygon here. Yeah, polygon as well, so I think I don't need these. Yes. Okay. I will change the via size, the default via size, to a rather to 0.8 and 0.4. Yes. Yeah, I think the bottom connection works better here. As I said, as I explained, there is no, the reason of using the octocouplers is not to get some clearance, it's only the possibility to isolate the ground of the waveform generator with the ground of the instrument. So this way I can easily shorten the clearance between the inputs, because as you can see, the real clearance is the clearance of the jumper connector, jumper header, not the clearance of the optocoupler. Sometimes the smaller via works better. And 0.3 millimeter PCB track width is no. I will change the default here. Okay, yes. Pin number 2 is power supply. Yes. Yeah, so I found myself being silent. Yeah, I'm working on a PCB layout, so it's not something, I don't know, crazy interesting. I'm looking for the best connection possibilities. I will connect this track later when the polygons for the MOSFETs are connected. What I know is there will be a bottom track connection. Definitely there will be a big polygon for the ground. Solid connection. Okay. With a bunch of vias. Horizontal, I guess 8. Let's try. Yeah, that can work. I think a little bit far from each other. Further from each other. Yeah, so I think 9. Into 2 rows, with the exception of this. Okay, that can work. Now the big cooling polygon. This is ground, but only small signal, low signal. Yeah, this is the BNC for checking the intermediate signal. So there will be some, I think, via. We have to connect this with a polygon. So this and this and this and this can be very narrow. This will be on the bottom. No, not here, not through here. Probably through here. Yes. This is the small or light load MOSFET, so the polygon will be below because the cooling capability can be lower. Okay. These tracks are only like auxiliary to see, to help me imagine where the polygons will be placed. So that can be like So I can make the priority of this one much higher, while let's try this one. So it's D10K. Yes. Solid, low priority level. Clearance will be 1 millimeter because I need some clearance around the BNC. And solid, as I said. Okay. So the polygon can go through the VCC will be connected on the bottom side, that's okay. I can remove this track. Yeah. Yeah, the reason for this, where I changed the priority to 20, is that it's a polygon inside the polygon. So like the initial one is the 0, 1, the cooling one, and then KiCad plays the higher priority polygon inside. And this is the ground one. And I'm going to use some fillet. Yes. Let's continue with the bottom polygon and see how it works. This is the measuring terminal, and yeah. I don't want to connect it to the big polygon. VCC. Did I change the clearance? I think I didn't. I wanted 1 millimeter as well. Yeah, there is a result of too high copper to edge clearance. Yeah, that's better. I want the pad to be covered. And there is a to save time, I change this clearance. Exactly, this is what I want. No. There's 7. That's it. Okay, so the polygon. For the VCC goes through these parts are quite narrow. Yeah, this is the snap to graphics feature. It snaps like crazy. Okay. I don't want to fight with you, so I will use the move exactly like this. Okay. Okay. Yeah, the not overlapped polygons irritated me so much. Now it's better. That's my OCD only. And I need I need the space for this. Best way would be go outside through here. I'm cutting the corner of the polygon by intense. What is that? These are the big issues that they say the 905 have. I expected yesterday would be released the 0.6, but it didn't happen because it took a week before the release candidate and the release version. So hopefully very soon, because as you can see, there are some issues with the KiCad. But that's annoying, developers. If you watch this, hold your nose. Because you didn't make a good job. Didn't make job. Anyway. That's really good commercial for KiCad. Okay, thank you. Am I cutting the corners of this polygon too much? I don't know. This is great. It's... oh. I don't want to get angry. So now the polygon for the channel, for the heavy load channel MOSFET, and here I can be more generous with the polygon area. I will be cutting the corners of it as well, because I have to. At least there must be a grounding polygon rather wide. There must be, as you know, the gate connecting track, gate driving track. Okay. Now the grounds. With high priority level, solid, 0.5 is enough. Is it or not? Isn't. But I don't think I can connect the pads with so high clearance. We will see. Yeah, 0.5. Now the LEDs, not LEDs, I'm talking now the vias. Yeah, I think it can work. Yeah, so the tracks for the octocoupler inputs. Ground connection.
For unlimited listening, head over to brain.fm or follow the link in the description below.
Yeah, I'm thinking, I think I know what they did. They changed the way how you can correct the shape of the tracks by pressing D. The D is drag 45-degree mode, yes. When you have active this constraint to horizontal, vertical, and 45, it fights with this dragging. So yeah, I think if I switch off this, it will work better, because at least for the positioning, it works much better than before. No. Five is out, 2 for power entry. See, now it works much better when I activate the constraint. I don't know. Sometimes it works, sometimes don't. Now I'm using the not high contrast mode. It's called dimming of inactive layers by pressing H. Normal is here. Sometimes when the layers are more crowded and I want to see more of the particular layer, it means where are the constraints, where the track can be routed or not. I use the dimmed mode. Now I'm using it for the power line distribution tracks. Now the polygon for the LDO. No. I have to rotate this decoupling capacitor. And possibly extend the polygon. While setting connections of these two thermals with 1 mm spoke width. Can it work? It can. Perfect. Nothing crazy beautiful, but it works. Okay. This is too close to the edge. Yeah, that's the 0.27 constraint I said before. But sometimes no, I need it here. Okay, like this. I can extend this polygon here. I have to move this terminal downward because it looks like I'm drunk, but I'm not. Okay, so I'm working on routing these signals to interfere as little as possible with the MOSFET polygon. Plus, I moved this monitoring terminal slightly downwards because I want it to be aligned with the line of the other ones. Otherwise, it looks awful. So much better. At least the terminals are in line. What about these two? If I moved them to the direction of the PCB, like to the center of the PCB, it would create the space for labels. That can be an improvement. So better or not? I think it's better. I will use only the polygons on the top side as a heatsink layer because I don't want to stitch the area with the vias because of the ground plane in the side and because of this track or terminal or polygon. Connection of this via must be moved outside of the crossing. This one. Otherwise, it looks strange. Much better. Okay, that's good. So let's work on the select screen and then the DRC, or how it's called? DRC, yes. I'm always confusing or mix the ERC and ERC. I'm removing the designators for connectors because these designators are not important at all. There will be labels in select screen for them. So when you need to navigate to a particular connector or jumper, you don't usually using the designator because we are going, you are looking for labels. Okay. So the area for the label here is too narrow, but we can move the hooks, the mounting holes more closer together, and then there can be, or far from each other. Far from each other can be better. Yes. Let's check how much space do we need. So VCC, how to call the labels, the signals, the VCC and the drain. Or switch, VCC and switch. So, or POF, no, VCC and SW. Okay, so VCC. .2. No, 1 millimeter. The other one was W. I don't know. Is it good or not? I will ask you, but there is nobody probably watching. No problem. I want and I need this PCB to be finished soon, as soon as possible, so I can live without comments today. I can live without them. I have to. Okay. No, this is too far. Yes, these VCCs can be really close together because they share the potential. Like this. This one. Yes. Yes. No. This is the heavy load. Yes, heavy load and light load. Okay. So this is the loads. So this is the same VCC and switch. Here will be light load, light. Can we have light load? Doesn't look, especially the gap between the lines isn't something I like, but why not? Is there? No, there is no line spacing here. I can learn every single day. Here. Yes, here, because it will mark the position of the jumper. I liked it. This is monitoring of the edges. Yes, so it means input or channel 2 driver, let's say. So channel 2 driver channel 1 driver Here is the ground. Ground connection. Yeah, it sometimes happens that the label is not created correctly.
For unlimited listening, head over to 𝗶𝗶𝗀𝗺.fm or follow the link in the description below.
This is channel 2 input. Channel 2 input. Channel 2 input. This is channel 1 input. I need space for labels here, so the reference generators don't work there. Don't work there. Yes. Continue with this. Yes. The same label. This is input. This is ground. We can call it ground because it's ground on the instrument. The VNC is clear. The inner wire, or I'm sorry, the pin is always the signal wire track, and the rest of the connector is ground. What's this? This is the input, yes. So something like this. But 10 volts instead of input. This is the big load. So this one is DUT VCC, and this one is DUT ground. I'm constantly hitting the E for properties, but the properties don't work for the KiCad 𝗶𝗶𝗀 labels. So yeah, it's a habit that's inside of my bones or muscles. Yeah, this is VCC, but this is monitor out. Label is here. Should be here. No. Channel 1 monitor. No channel 1 monitor. This is not monitor, this is the VCC. This is the DUT monitor. Yes, as well as this one. Okay, let's check. Now it works. This is the position where the instrument will be placed on my desk. So I think these two, these there are missing, here are missing the labels, and here as well. Not so much, because you can extend the validity of this label to this mounting hole, so it can work. Channel 1, channel 2, and now the labels for this. I have to go below 1 millimeter, I don't know if it works. And use a shorter padding on left or right. Okay, it can work because 5 volt is probably a little bit narrower. Oh, it isn't. I want the inversion mode. But yeah, a little bit narrower. It's good. I think that's so good that probably I will use the same strategy on the other labels. What do you think? Yeah, I will. Ah, so much work. So the right one will be sharp. The left one is sharp. Right one is sharp. Left one is sharp. Where here, so right one is sharp. Left one is sharp. Where else? Here. Right one is sharp. Left one is sharp. Okay. I will edit it because otherwise I would have to switch them. And I'm too lazy to that. Okay. Fast check. LEDs. LEDs. So this is channel 1, 𝗲𝗲𝗀, with the arrow on the right side and sharp on the left side. No, it's channel 1 output. Channel 1 output and channel 2 output. And this is channel 2 input. So in and sharp from both sides. Okay, it can work. Channel 1 in, channel 1 in, channel 1 out, channel 2 out, channel 2 in, channel 2 input, channel 2 input, ground in, ground, channel 1 input. Okay, ground 5 volts, ground 10 volts, VCC ground. Okay, okay, driver, light load, heavy load, driver, MOSFET, channel 1, channel 2, on. Okay, that's fine. So, DRC. Let's check. Two errors. Let's start with errors. Cartridge, yeah, we know. We know that's by intention. Yeah, as I explained, these cartridge overlaps because we need, or I need the possibility to replace one header 2 times 4 or 2 headers 2 times 2. So yeah, I know about that. Select screen clipped. Yes, the BNC clipped as well. Yes. Here. Okay. Only clipped select screen as well as here. Select screen overlaps. Yeah, I know. So only select screen related findings, warnings. That's good. That's good. That's good. So. Okay, I think we are done. 2 hours 40 minutes. Yeah, KiCad for makers. It's my newest tutorial on 𝗲𝗲𝗀, so feel free to check it. We will design this PCB with Raspberry Pi, dual core RP2350A, 2 power supplies, M2 connector, M2 connector for 2 node cards, 2 USB-C SIM card slot connectors, bunch of LEDs, 4 power outputs, 4 analog inputs. Everything is there for you to create and design a working platform. It's Arduino compatible. And in the last section, in the last part of the tutorial, I was presenting, or I am presenting, the function of the device. It works. It sends values to the internet. It receives commands from the cloud, from the internet. it works like a charm. I tested it with the Wi-Fi node card. Okay, so thank you for watching. I think we are done. The board is finished. I think it's ready to be manufactured. After a short break, I will take a second look and then I will send it to the manufacturing floor. So, can it work, do you think? I think it can. Hopefully it will. There is not a big deal. And I think we together did a good job. Thank you for being here. Thank you for watching. This stream was longer than usual and took place on another day, on a different day, because I need this board to be finished as soon as possible, and Thursday afternoon is too late. So thank you and have a nice day. I'm concluding the stream. Bye bye.